So chapter 6 is going to get deeper into the graph of polynomials. And polynomials typically the graphs look a little bit more complicated than just a line or a parabola. They tend to have more curves to them, different things going on. So it can be kind of helpful to pick out common characteristics that work in all polynomials, or something that we can refer to. End behavior is the first of a couple things we're going to talk about with regards to that. So when you're talking about the end behavior, you're basically asking yourself, what's going to happen to the graph when you go really far to the right? So when you plug in really, really big numbers for x, and when you go really far to the left. So when you plug in really, really small negative numbers, -1 million, -2 million, etc. Is the graph going to be going up? Is the graph going to be going down? Is it just waving back and forth between two numbers? Whatever the case may be, basically. So if you look at this first graph here, as we go to the right, if we're going to the right here, so I guess if we're actually on the graph, we would be going like this. As we go further to the right, following the graph along, it's pretty clear that the graph is going upwards. If I plugged in a number way over here on my number line, my result's going to be way off the page, but it's going to be really high up. As you go farther and farther to the right, this graph is just going to keep going up. So what I'm going to do, I'm going to show this two ways. The first way, I'm going to draw little arrows here, just to kind of refer to the ends of the graph. So as we go to the right, the graph goes up, and as we go to the left, you plug in really, really, really big negative numbers, the graph gets bigger and bigger as well. So I'm going to kind of draw my end behavior with two arrows, and just kind of put it in a parenthesis like this. This is like kind of it's not a very official way of writing end behavior, but it's kind of helpful. When you go to the left, the graph goes up. When you go to the right, the graph goes up as well. Now we actually have to talk about how to write this. So when you write end behavior, you write it as kind of two sentences. There'll be two parts to it. The first one is going to say as x, and I'm going to draw a little arrow here and put an infinity symbol. So as x goes to infinity, that's another fancy way of saying as x gets really, really big. So as x gets big, y gets big as well. So y, another way of writing y is f of x. So f of x approaches positive infinity as well. So as x goes really far to the right, y, or f of x, goes really high up. Okay? The second part of it, that took care of this guy right here, the first arrow, or the arrow on the right. I have to write a line for this one too. So as x goes really far to the left, that means that x is going to go towards negative infinity. So as x approaches negative infinity, as it goes really far to the left, the graph is still going upwards because we have this arrow right there. So we have f of x approaches positive infinity. It's a way of describing what direction the graph goes when you go really, really big numbers or really, really small numbers in each situation. So this takes a little getting used to, just a couple examples, but you'll kind of get the hang of it. On this graph here, if we look to the left, if we go really far to the left, this graph is going upwards. It's going to keep going up, 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 up as we go further to the left. So on this end of things, that's my end behavior. And on the other end here, as we go to the right, the graph is going down. So if you go farther, farther, farther to the right, the graph's going to go down. That's going to look, as we go to the right, we go down. So this is one way of writing the end behavior. It shows left is up, right is down. And let's write our little sentence like we did on our last example. So I guess this one, there's no real reason I started with the right side on this one. I'll just start with the left here. As x approaches, if we're going to the left, that's going to be negative infinity. F of x was going upwards to the left, so it's going to approach positive infinity. On the second part here, if we go to the right, so when we go to the right here, as x approaches positive infinity, f of x is going to approach negative infinity, because as we go to the right, the graph goes down. So arrow, negative infinity. All you're doing, the only way the end behavior is going to change is whether you put a positive or negative infinity. The setup is the same for all of them. You just change according to whether it goes up, down, left, or right. I have two more examples here. This would be probably a good place for you to pause the video. You can try them for yourself and then just see if you got them right afterwards. I'll try to go quicker through these. So on this one, end behavior, to the left it goes down, to the right it goes up, so it looks like this. And for our statement here, when x approaches negative infinity, that's going to the left. F of x is also approaching negative infinity, it's going down. And for the second line here, as x approaches positive infinity, so does f of x. It's going up as well. So that's this one. And for my last example, when you go to the left or to the right, it goes down in both directions. So my end behavior on this one is going to be going downwards twice. So as x approaches negative infinity, f of x approaches negative infinity because it's going downwards. And as x approaches positive infinity, f of x is still going to approach negative infinity here. So I kind of blew fast through those examples because I hope you will get the idea and you can practice these. But end behavior basically describes what happens when we go to the left and right on our graph.